Stop guessing plastics, ABS or polycarbonate. Here's the real world answer. You hold a new electronic gadget in your hands. It feels solid, smooth and perfectly shaped. But have you ever wondered what it is actually made of? Chances are it is made from one of two incredibly common plastics, ABS and polycarbonate. These materials are everywhere, toys and helmets, yet they are fundamentally different. Engineers, designers and curious consumers ask the same question, which is right for the job? This question can feel complex, but the answer does not have to be. We aim to demystify these two materials using simple words and real-world examples to help you stop guessing and start choosing with confidence. First, let us get to know ABS. The name sounds technical, Acrylonitrile Butadiene Styrene, but its purpose is wonderfully straightforward. Think of it as the reliable, all-around player on the plastics team. It is not the strongest, it is not the most heat resistant, yet it offers a fantastic combination of useful properties at a very reasonable cost. This balance makes it one of the most popular engineering thermoplastics in the world. One of its most celebrated traits is its excellent surface finish. Smooth, glossy, professional. It takes color very well, allowing for bright, vibrant products that catch the eye. Another key property of ABS is its good mechanical strength, stiffness. While it will not stop a bullet, it provides more than enough durability for the bumps and knocks of daily life. This is why it is used for things like computer keyboard casings, power tool housings, plastic trim inside your car. Furthermore, ABS is relatively easy to process. Low melting point, flows well in a mold. Now let us turn our focus to the heavyweight champion of the plastics world, polycarbonate, often simply called PC. If ABS is the versatile all-rounder, polycarbonate is the specialist brought in for the toughest jobs. Its single most defining characteristic is its incredible impact resistance. It is exceptionally tough and shatter-resistant, capable of absorbing tremendous amounts of energy without breaking. This makes it a premier choice for safety applications where failure could have serious consequences. To put its strength into perspective, some grades of polycarbonate are used in the creation of bulletproof glass and riot shields. Another standout feature of polycarbonate is its high heat resistance. Unlike ABS, which can soften at relatively modest temperatures, polycarbonate maintains its structural integrity up to about 120 to 135 degrees Celsius. This quality makes it ideal for components that are near heat sources or operate in high-temperature environments. Housings for high-intensity lighting, components inside electronics that generate a lot of heat. Perhaps one of the most visually striking properties of polycarbonate is its excellent optical clarity. It is the reason why the lenses in most modern eyeglasses and sunglasses are made from polycarbonate. It protects the wearer's eyes not only from UV rays, but also from physical impact. Of course, this superior performance comes at a cost. Polycarbonate is generally more expensive to produce than ABS and requires higher temperatures and pressures during injection molding, and while extremely tough, its surface is softer and can scratch unless a special hard coating is applied. To truly understand the difference between these two materials, it is helpful to place them side by side and compare their key properties using simple numbers and descriptions. This direct comparison acts as a practical guide, stripping away the complexity and revealing the core trade-offs a designer or engineer must consider. By looking at the data, the choice between ABS and polycarbonate becomes less about guessing. Let us break down the most important factors one by one: impact strength, heat resistance, aesthetics and transparency, and cost. First, let's talk about strength and impact resistance, where polycarbonate truly shines. The impact strength of a material is often measured in joules per meter. While standard ABS has around 200 joules per meter, polycarbonate boasts approximately 600 to 800, 3 to 4 times higher. Likewise, in heat, ABS at 80 to 90, PC at 120 to 135 degrees Celsius. Making the right choice begins with clearly defining your product's most important requirements. You should choose ABS when your primary concerns are keeping costs low. You should choose ABS when you need a beautiful, high-quality surface finish. It is ideal for mass-produced items where visual appeal matters but extreme performance doesn't. Think of products that live relatively gentle lives, sitting on a desk, sitting on a shelf, sitting in a living room. For these, polycarbonate is overkill and more expensive. Consider the casing for a television remote control. Consider the casing for an internet router. They need to look good in a home environment with a smooth, pleasant finish. They also need to survive the occasional drop from a coffee table. They are not exposed to high heat or extreme forces. Using polycarbonate here is like building a garden shed out of reinforced steel, therefore for consumer electronics housings. ABS is the workhorse that gets the job done reliably, beautifully, and affordably. There are times when good enough is not good enough. You should choose polycarbonate when the primary requirements are exceptional strength, high impact resistance, and dependable performance under heat. It is the material of choice where safety is paramount, and failure could cause injury or system malfunction. When a part absolutely must not break, shatter, or deform under stress, the higher cost becomes an investment in reliability and protection. Think about products designed to protect us. The clear visor on a motorcycle helmet, the safety glasses worn in a workshop must stop a fast-moving particle. In these scenarios, the optical clarity and incredible impact strength of polycarbonate are non-negotiable. Using a weaker material would be a dangerous compromise. What if you need more toughness than ABS can offer, but you cannot justify the high cost and processing challenges of pure polycarbonate? This is where a blend shines. PC-ABS balances strength, heat resistance, finish, and cost. So the final answer is simple. For cost-effective parts, go with ABS. For high-performance, unbreakable, heat-resistant parts, go with polycarbonate. And for a perfect balance, choose PC-ABS blend. Both plastics are amazing. The right choice depends on your product.